In this video, we're going to discuss polynomial functions, and we're going to specifically focus on cubic functions. A polynomial function is any equation, any function where y is equal to x raised to some number that is not negative. So for example, we've already looked at y is equal to x, which is a linear function, which means that it crosses the x-axis maximum one time. We've looked at quadratic functions, y is equal to x squared, which is a parabola that crosses the x-axis maximum twice. Now, of course, we could have a double root where it only crosses once, and we could have a graph that doesn't cross at all, like that. But maximum, a quadratic function will cross the x-axis two places. We're going to focus in this video on cubic functions. A cubic function is y is equal to x cubed that crosses the x-axis maximum 3 times. 1, 2, and 3. Now, of course, we could have a cubic that will cross only once. We could also have one that will cross only twice, but maximum 3 times. It's important to know how the factors of a cubic function relate to the roots of the function. Let's say we have a cubic function in factored form. Y is equal to x plus 4 times x minus 1 times x plus 2. This is factored form. We could FOIL it out and get it in standard form. And standard form would be y is equal to ax cubed plus bx squared plus cx plus d. But this is in factored form. We have our 3 factors. Let's graph it and see how it looks. X plus 4 times x minus 1 times x plus 2. We'll graph it in zoom standard, so zoom 6. Notice that it crosses the x-axis in 3 places. It's a cubic function. Now, without graphing it, how would we know where this cubic function crosses the x-axis? If you remember when we had quadratic functions, let's say we had y is equal to x plus 2 times x minus 1. To find where the quadratic function crossed the x-axis, to find the x-intercepts, to find the roots, to find the zeros, they're all the same thing, we set each of the factors equal to 0. So we did x plus 2 is equal to 0, and then we solved this, minus 2 and minus 2, x is equal to negative 2. And the other factor also, x minus 1 is equal to 0, plus 1 and plus 1, x is equal to positive 1. So the 2 roots of this quadratic function, the 2 x-intercepts, the 2 zeros, would be negative 2 and 1. So this quadratic function would cross the x-axis at x is equal to negative 2 and at x is equal to positive 1. For a cubic function, we're going to do the same thing. Let's move over the function. Y is equal to x plus 4 times x minus 1 times x plus 2. So this is our cubic function. If we set each of these factors equal to 0, then we will get where this cubic function crosses the x-axis. So x plus 4 is equal to 0. We're going to solve this for x, so minus 4 and minus 4. X is equal to negative 4. This is one root. Then x minus 1 is equal to 0, plus 1 and plus 1. X is equal to positive 1. This is another root. X plus 2 is equal to 0, minus 2 and minus 2. X is equal to negative 2. This is another root. So the graph of our cubic function would look like, it would cross over here, it would cross over here, and it would cross over here. And the cubic function would look something like this. If you notice on the graph, when we graphed on the calculator, this is exactly how the graph looked. We had our x-intercepts at x is equal to negative 4 over there, at x is equal to negative 2 over there, and at x is equal to positive 1 over there, which is exactly what we got when we graphed it on paper, finding the roots. It's important to recognize when you have a graph, let's say the one that we just drew, you have to be able to, if they give you the roots, you have to be able to find what the factors are, to be able to work backwards. So in this case, if you look at the graph that we drew, this root over here is x is equal to negative 4, so there's a factor of x plus 4. You always switch the sign. If there's a root over here of x is equal to negative 2, there's a factor of x plus 2. We switch the sign. And if there's a root of positive 1, we switch the sign, and there's a factor of x minus 1. Let's look at one more graph like that. On the screen now is a screenshot of a cubic function that was graphed on the calculator. And we want to write an equation for this polynomial function. To do that, we need to find the factors, because we don't need to write it in standard form, we could write it in factored form. And in factored form, we're going to have three factors. So we're going to have y is equal to x plus or minus something, times x plus or minus something, times x plus or minus something. And we need to find what those factors are. To do that, we need to find the roots and then switch the signs. So let's look at the roots. This root over here is x is equal to negative 3. That means that we're going to have a factor of x plus 3. We always switch the sign. Let's look at the next root. The next root is x is equal to negative 1. So we're going to have a factor of x plus 1. And the next one is x is equal to positive 6. So we're going to switch the sign, and we're going to have a factor of x minus 6. So these are our factors. If we would FOIL this out and multiply this out, we would get some sort of polynomial ax cubed plus bx squared plus cx plus d form. This would be standard form, but we can just leave our answer like this in factored form. Let's graph it to see if that's what our graph looks like. So x plus 3 times x plus 1 times x minus 6, and graph. And notice this is exactly what our polynomial looks like. We have the graph crossing the x-axis at x minus 3, at x minus 1, and at x plus 6. So that's how you would write the equation of a polynomial if you're given its graph or if you're given its roots. If you are just given the roots of a polynomial, let's say you're told the roots of a cubic polynomial that are negative 6, positive 1, and positive 3. It's very easy for you to write an equation for this polynomial in factored form. You generally won't even have to simplify it. So you just do y is equal to x plus or minus something, x plus or minus something, and x plus or minus something. So then we always switch the sign of the roots and just fill it in. So the negative 6 is going to become a plus 6. The positive 1 is going to become a negative 1. And the positive 3 is going to become a negative 3. And this would be an equation for the polynomial with roots of negative 6, positive 1, and 3. Let's see why that works. To solve this polynomial, let's say we didn't know the roots of this polynomial. And we were told to solve this polynomial for its roots. What would we do? We would set each of the factors equal to 0. So x plus 6 is equal to 0. X minus 1 is equal to 0. And x minus 3 is equal to 0. Then we're going to solve each of these. Minus 6 and minus 6. X is equal to minus 6. This is a root. Plus 1 and plus 1. X is equal to positive 1. This is a root. Plus 3 and plus 3. X is equal to positive 3. This is another root. Notice that these roots are the exact same roots as the ones that we got before. One more important thing to be able to do is, let's say you're given a polynomial function y is equal to x plus 4 times x squared minus 5x plus 6. And let's say you're asked to solve this polynomial for its roots. You want to know what are the roots, what are the zeros, what are the x-intercepts of this function. So you know that what you always have to do is set each of the factors equal to 0. So this is in factored form, so x plus 4 is equal to 0, and this is very easy to solve. So just subtract 4 and subtract 4. X is equal to negative 4. This is one of the roots. This polynomial function crosses the x-axis at x is equal to negative 4. And then we have the other factor. X squared minus 5x plus 6 is equal to 0. How are we going to solve? Notice that the right side of this equation is a quadratic function because the highest exponent is 2. How are we going to solve this function? First, when it's set equal to 0, we need to solve it for x. We have to factor this right-hand side. It wasn't given to us in completely factored form. It was only partially factored. So we need to factor this right-hand side of the equation so we could set each of the two factors equal to 0. So to do that, we need to find factors of positive 6 that add up to negative 5. Factors of positive 6 are positive 1 and positive 6, negative 1 and negative 6. positive 2 and positive 3, negative 2 and negative 3. The factors that add up to negative 5 are negative 2 and negative 3. So we're going to write out our factors. X minus 2 times x minus 3 is equal to 0. So now we're able to, once this is in completely factored form, we can set each of these factors equal to 0. X minus 2 is equal to 0, and x minus 3 is equal to 0. We're going to plus 2 and plus 2. X is equal to positive 2. Plus 3 and plus 3. X is equal to positive 3. So this cubic function would cross the x-axis at x is equal to negative 4, at x is equal to positive 2, and at x is equal to positive 3. So the function would look something like this. Let's graph on the calculator to see. X plus 4 times x squared minus 5x plus 6. And then we'll graph it in Zoom Standard. Notice that this cubic function crosses the x-axis at x is equal to negative 4, at x is equal to positive 2, and at x is equal to positive 3. Those are the roots of the function.